name is Thomas Betancourt. This is my presentation for the IBM Advanced Data Science Capstone. The subject of this project is predicting power usage with scikit-learn. So the purpose of this project is that we will attempt to use scikit-learn with rich regression to predict power usage 1 hour in the future average in 24 hours, and the future maximum use 1 day ahead, aggregated by day. When we say aggregated by day, we mean a calendar day. Rich regression was chosen because it's good for shorter series, which is true for the aggregated days. Normally, for a series of days, you would want up to 3 years. Here, we only have 2. We have used scikit-learn because it's easy to integrate with PyTorch and other deep learning tools, which is the next step. First step is to extract the data. We extract the data for hourly power usage over 2 years in the contiguous 48 states of the Northwestern region. The 48 state series was tested with the Dickey-Fuller test. The power consumption for the Northwest served as test data. Here we have the results of the Dickey-Fuller test. You can see that, well, the standard deviation and the rolling average change through time. They don't change in any continuous upward or downward fashion. This is what we mean when we say a series is stationary. And in this case, the Dickey-Fuller test said with 99% certainty that it is. This means that the techniques we're using are valid. Now that we've confirmed this, we try the first model. We'll use the continuous 48 states for a test, for a training and test set, and then we'll validate on the Northwestern state's power demand. We use mean absolute error and CV grid search to test the model. We'll use R-squared to evaluate, because R-squared measures the variance from the predicted versus the actual test data, and variance should be stationary in this series. The R-squared value is 0.977 for the validation set on the Northwest data. This is unusually high, but again, for a large time series with a lot of data points that is stationary, this would actually be expected. Here's a graph showing that there's a large overlap between the predicted and expected data, or between the predicted and the test data. Next, we move on to predicting periods. Next, we move on to predicting rolling statistics from rolling statistics of the previous 24 hours. So if we set the test for 1 hour ahead, we get an R-squared of 0.99. This is expected because 23 out of 24 hours would be the same in both sets. So when we set the gap to 24 hours, we find that the R-squared goes down to 0.85. This result is still unusually high, but again shows the regularity of the series. This graph will also help illustrate that point, which shows the predicted versus the real values. You can see that they essentially overlap entirely. As you can see here, we have a graph of the R-squared versus the time ahead. And you can see that it drops off very sharply from a very high value to what is still a high value, but which is substantially different from the initial value. Finally, the maximum power usage for a day, that is a calendar day, was predicted. Daily aggregates for mean, standard deviation, sum usage, and maximum were taken. Workday and summer seasonal effects were found to diminish the accuracy of the ridge regression, but increase the accuracy for a long short-term memory neural network. The R-squared was 0.873 for 1 day ahead on the validation set for the ridge regression. Here is a comparison between the results of the ridge regression and the neural network for sparse data. As you can see, the neural network performs close in value to the ridge regression, but is actually less accurate in this example. However, when you add in more data, such as the workday, day of the week, and seasonal data, the neural network becomes substantially more accurate. And in fact, the ridge regression becomes completely inaccurate, suggesting that for future efforts, for predicting aggregate data for a day, one should explore the use of a neural network rather than regression methods. So I hope that was informative, and I wish everyone well. Have a great day.